523, moving right along. This is just a big old mixed bag of nuts, if you want to call it that. Logarithms, exponential functions, logarithmic equations, and we're going to solve them. Every one of them has a little different characteristic, so there's no like one way to do these. That's what's fun, okay? Start with this one. So, repeat after me. Common bases, I heard you. Happy places. That's going to work real good for us right here. So I see a 3 and a 27. Yes, this should be a little bit of a review, so that's 3 cubed. So I'm going to rewrite this as 3 to the x minus 2. And what I'm going to do is bring this up. So I'm going to erase it, make it 3 to the negative third. Power to a power you multiply. So I get positive 9x. These disappear, so I get x minus 2 equals 9x. Subtract x, I get negative 2 equals 8x, divide by 8, divide by 8, you can see x equals negative 1/4. So that's that one. Now, I'm going to compare this one to this one. Common bases, happy places? I don't think so. Never going to work. You got these nice math problems that work, and it's like, whoa, doesn't work. Well, I call this a chilly math problem because when it's chilly out, you put logs on the fire. There's your little humor for the day. So I'm going to slap a log on this side, and I'm going to slap a log on this side. And now, for the first time ever, you're using logarithms to solve these impossible to solve problems without them. I'm going to use law 3 because we're trying to find x. I get to bring it in the front. So I get x times, and I want you to notice something. By slapping logs on, you are kind of getting common bases. So that common bases, happy places, it does apply, but you got to slap a log on to make that happen. So now I'm going to figure out what log of 3.23 is. So here we go. I don't have my glasses. Big mistake. Where's the log? Oh, there it is. Log 3.23 is 0.509. 0.509. I'm going to figure out what the log of 4 is. Log 4, enter. That's 0.6. So now I'm going to divide this side by 0.509. Gone. Divide that by 0.509. So, divided by 0.509, I get 1.182. So x is 1.182. All right, that is a very unique problem right there. I'm going to erase all this to give us some more space to work for these other ones. And let's go to number 3. Well, according to just basic rules, let's just clean this thing up. So I get negative 4 times 6 to the x power equals negative 5. Now, if you try to go negative 4 times 6 and get negative 24, you're breaking the commandment of PEMDAS. So divide by negative 4, divide by negative 4, and I get 6 to the x equals 5/4. Common bases, happy places? Never, ever, ever. Slap a log on, slap a log on. Bring the power in the front. So x times log of 6 is 0.778. I don't know how precise you want to get. You could round that to 0.8 if you want. And then I get log of 1.25. Log 1.25, 0.096. Divide by 0.778. Divide by 0.778. And I get 0.124. So x equals 0.124. No way can you solve these without your logarithms. And there are some real-life application problems coming where you're going to see this actually used in some formulas. So there's that. 2 more. I'm going to have to pause. Look at this mess. Exactly. So we've got to clean this up. So we're going to take a look at this first. the 2 shall become 1 by multiplication. So I get log base 2 x to the 4th power minus log 2 3x equals 8. Now again, I'm going to use the rule. The 2 shall become 1. Subtraction means division. Log base 2, x to the 4th in the top, 3x in the bottom, equals 8. Now, even though this looks really weird, here's our base, here's our exponent, here's our answer. So we get 2 to the 8th equals x to the 4th all over 3x. Now 2 to the 8th, I think it's 256, but I don't want to screw this up. 256. So I get 256 equals x to the 4th over 3x. Now I can reduce this, and I should have a while ago. X to the 4th over x reduces to x cubed. I'm going to multiply by 3, multiply by 3. So times 3, 768 equals x cubed. Now I'm going to take the cubic root of this. Now the cubic root is the same thing as raising a power to the 3rd power. So 768 raised to the 0.3333 power, 9.15. So I get x is 9.15 out of that crazy looking math problem. Again, we're going to need some space for this last one. It's not really the last one, we got a couple more, but all right, this one's kind of unique. Now, this is screaming out law 3. Remember, even if it's there, I could put it there if that's more comfortable for you, and then I can say, hey, I can bring it in the front. Now, why would I do that? Well, I showed you in a previous lesson that whenever ln shows up, it equals 1. Oops, I meant to write a 3. So this is the same thing as 2 times 1, which is just 2. So I get 2 ln x equals 5. Divide by 2, clean it up. Natural log of x is 5 halves. Remember, when there's a natural log here, there's an indivisible e. Now I know what to do. E to the 5 halves power equals x. Got it. Now if I really wanted to find out what this was as a decimal, I'd go 2.71 and I'd raise that to the 2.5 power, 12.09. And I don't know if they're going to let you leave it here or they want you to take it here, I'm not sure. But 2 more of those, I think, and I think it might do it. So, why so many problems? Well, there's a lot going on with these, and each one of them has a little different twist. So after I cover these 3, we should be good to go. So what do I do here? Well, take the easy algebra route and just divide everything by -10, divide everything by -10, clean it up. So natural log x minus 1 equals 7/10. Not all of these are going to come out all nice. Because that's a natural log, there's an e there. So I get e to the 7/10 equals, remember, here to here to here, x minus 1. So I add 1 to both sides, and I get x is 1 plus 2.71 to the 7/10 power. Now, I don't know if they're going to let you leave your answer here or not, so let's go ahead and type this in and see what we get. 2.71 raised to the 7/10 power is 2, like flat out 2. So 2 plus 1 is 3 now. So I'm going to put a little squiggly because it is close to 3. Okay? So that one gets a little tricky, but not too bad. Last 2. Well, again, the 2 shall become 1 by multiplying these things together. So we're going to go log 4, and then we go x plus 2 times x minus 3 equals 1. what do we do with this? Well, FOIL it. So we get log, I'm going to do a little bit in my head, x squared outside inside is negative x minus 6 equals 1. Well, base, power, exponent, base, exponent, answer. So I get 4 to the first power equals x squared minus x minus 6. Well, now this takes you into trinomial land. Subtract 4, subtract 4. You say a little prayer and you're hoping that this is factorable. And 5 and 2, there's no way we're going to get a negative 1 there. So A is 1, B is negative 1, C is negative 10. So negative B is 1 plus or minus the square root of B squared minus 4 times A times C all over 2A, which is 2. Now this is 1 plus 40. So it's 1 plus or minus the square root of 41 all over 2. Crazy answers, but there it is. Last one, if I can squeeze this one in. All right, this one's got some trick to it. So I look at this and I go, hey, there's a log on this side, there's a log on this side. That means this stuff has to equal that stuff. And the logs just disappear. So y squared equals 5y plus 24. So y squared minus 5y minus 24 equals 0. And you're like, well, what's the tricky part of this? Well, y minus 8 and y plus 3 equals 0. And you're like, sweet, this one's working out. 8 or negative 3. Here's the tricky part. You can never, ever, ever have a negative in that spot. For example, if I have a 10 here, and I have any power here, any number to some power will never, ever, ever give you a negative. These bases are always positive, so you can't raise a positive number to any power and get a negative. So if I take that 8, and I pop it in here, I get 64. 40 plus 24 is 64. It's like, cool, that one worked. But if I put this negative 3 in, I would get 9 here, which is all fine. Oh, wait a minute. I gotta pause this. Oh, no. So, if I put a negative 3 in here, I get 9. And if I put a negative 3 in here, I get negative 15, and I get a 9. Now, I'm saying, what if? What if we got y is like negative 7? If I got something like negative 7 here, and I put it in here, I get negative 35 plus 24. That would give me log 4 negative, and that's called an extraneous solution. So I'm just throwing that out there, just for the FYI part of it.